Yeah, good morning, everyone. I hope everyone has joined. Hello, hello, hello. Can you hear me?
Yeah, good morning.
Yeah, good
Yes,
morning. Good
we can
morning.
all hear
We
you.
can hear you.
All right,
I,
all right.
I suggest we just wait a little, few more
Yes,
minutes
yes,
for more
yes,
people to
yes.
come in.
Yeah, yeah, yeah. Okay, no
Thank you.
problem.
Thank you.
Yeah.
Good morning, colleague. Are we still on?
Yeah, hello. Very good morning. Yes, I think we are starting very soon. As seen, like people are still joining, we expect a few more people to join so that we can start. Maybe,
Okay, sir.
probably, yeah, maybe for 2 to 5 minutes. That's it, and then we'll start it. Yeah,
Thank you, sir.
yeah. Thank you. Yeah, very good morning to everyone. I believe people are still joining. So we would be starting meanwhile. So I request again everyone to at least, call up for those who are still yet to join so that at least they can be, on same page. So they are not lagging behind. So yes, I think we can start. It's good to go, or shall we wait? Because I can see still there are 15 attendees, but
He suggests we start like 10, according to
okay,
the timetable provided by the NSA. Let the
okay, okay,
registration come in that in 12 minutes,
okay,
in 10 minutes time we start. Thank you, sir.
okay. Thank you. Okay.
Hello, sir. I am trying to add you to the workshop. Engineer Idris said that, sir. Okay, okay, thank you. You see the link? Okay, I'll send the link to you. It's a Zoom link. I'll send it to you. You open it and click the link. Okay. We'll start in 5 minutes time. Thank you.
Yeah, that's right. So meanwhile, we start. So I expect if you have any questions pertaining to yesterday's session regarding 2D box culvert design, and also I would appreciate if someone would have tried post our, I mean, the session. Do let me know if they have come up with certain queries. Meanwhile, we can resolve them. And once it's 5, it's at exact 10, we'll start with the today's session. Please let me know if you have any queries.
Okay, good morning, everybody.
Yeah, good morning.
Good morning, our able instructor, Jinashke.
Yeah.
Okay, so my what I have is not really a question, but
Mm-hmm.
it is an appeal because yesterday, at
Mm-hmm.
some point in the yesterday, I was having network issues, and then due to activity call for duty. As joining virtually, I had to manage joining the training and also what I am doing. So, but as a result of call for duty, I had to skip so many some vital sections. So, as a result of that, when I went home and I was practicing with the manual and all that, I got stuck at some point. But now we cannot say let's go back and redo what we did yesterday. So that's why I'm like, if the recorded video could be shared so that
Okay.
it can help to catch up with those things, because I know some of them were addressed during the during your illustrations and the instruction. Thank you.
Certainly. So I would request from to NSC regarding sharing the recorded link session. So it might be, maybe today we'll share it for both the sessions.
Okay, thank you so much. I appreciate
Yeah,
that.
yeah, yeah.
Hello.
Yeah, hi. Hello.
Morning. Okay.
Morning. Very good morning. Yeah.
Yes. Yeah. Okay. I was trying out the exercises yesterday. I didn't notice a difference between the 2D
Uh-huh.
and the 3D culverts.
Yes.
They all came out, almost the same, looking the same.
Yes, yes, yes. So particularly, why there is an approach of 2D and 3D. I think this is a very valid question being asked, like why we have to go with a 2D approach, and other way, like what would be the benefit of using a 3D approach, right?
Mhm.
So
Okay.
when I say 2D, it's a very approximate, because what you do in 2D is we simply apply the loads in a one direction or one plane. Okay, so the actual span or the actual model of what we say for dispersion of moving load, and setting up with the exact distribution is not captured in 2D. However, most of the engineer prefer to adopt 2D approach just because it is simple and easy to adopt. However, when we have a criticality of being a skiff or maybe a certain loading to be applied onto the bridge, so preferably or more accurate method is to go with a 3D approach. So
Okay.
the differences you can get is the actual loading position, as we don't apply any more static load over here. And also, secondly, you could get the exact design forces in distribution along with the positive and the negative direction.
Okay.
Yes.
The other question was that when you try to trace
Yeah.
the moving load tracer, you entered an element, a key element
Yes.
number 52.
Yes.
It's
Yes.
not clear to me how is that an arbitrary selection?
Maybe I'll explain that when today we are going to do that exercise. But
Okay.
just to clarify first, the moving load tracer would give you the exact position of being, you on the but let's say if you already know what is the element, so to determine the position and convert it into the static load, for that purposes moving load tracer is being used. So I'll explain that, maybe it will be much more clear when it comes to the demonstration. However, as of now, just remember that it will determine the position, and how to determine based on the maximum element, that also I will explain for today.
Okay.
All right. So I think uh, now
Are you
let's start.
starting?
Yes.
There was a question I sent to you. I didn't see some of those other Windows editing tools in
Regarding.
the user interface of Civil NX, like undo,
Mhm.
some of those common functions that we use from
Okay.
Windows.
Okay.
Where are they
Uh,
hidden?
just a minute. I referred to your questions yesterday. So regarding, the wizard thing, right, that you have mentioned yesterday regarding the closing of the wizard, if I'm correct.
Yes, you're correct. Like if you're in the middle of
Yes, yes, yes,
using a
yes.
wizard and you need to shut
Right,
down, how do you save what you have done?
right, right. So let me show it to you. I think I have explained that, but let me reiterate today that for that thing as well. So basically, like this is something which is very valid, as I have been discussing. Let's say if you are going to define any of the example problem. Let's say if you're going with a multiple, let's say if you have 10 box culvert to be
We're
designed.
not seeing your screen, sir.
Oh, just let me share it. Yeah, I forgot to share. Can you see now?
Yes,
Just
it's
let me know
coming
when
up.
it's
Yes,
visible.
yes.
Yeah, yeah. So basically, when you're defining the set of data, you need to save it. So this will be certain reference which would save the wizard file as .wzd. Okay. So this is something, the input data saved in this wizard would be saved for your reference. So let's say by mistakenly, if you close the window, or let's say if you cut down the window, then again with the same part, you can go it and you can just open the wizard file, so that all the saved input data would be seen over here. So that's the only difference that we have, or the advantage we have of using the save as option over here, saving the wizard file. Again, let's say if you are working with multiple box culvert projects, and at the same time you have the change of certain span, or let's say a cross section. So in that case only it will be helpful. In that case, it will be much more helpful to, or what we say is to just alter the data using the same wizard file. And let's say at some point of time, if you wanted to do some actions, so the undo redo button option is available over here. As I can see into this option over here at the undo redo tab, you have
Okay,
this
okay.
option over here. So maybe you
Uh,
can just check the
yes,
link.
I've seen them.
Yes, yes.
I've
So
seen them.
first you need to ensure that, first thing is, the very thing is, you need to ensure that you need to check the list. Okay. So let's say if already have this thing. Okay. So you can see that this list will appear. If I delete something from the tree menu, it will appear over here. Or if you add something, it will appear over here. So you just have to select it and press undo. Or you can use Control Z as well. But make sure that it is being or it is being you know undone only at once, so that you are not missing out your data which has been already done, right? So this is the undo and the redo command that you can find it. Clear?
Okay, okay.
And also, I think third question is how to save automatically, right? So Midas will, by default, it will save you the data file in every other 5 to 2 minutes interval. If you want that it automatically to be saved, it is automatically saved by default. Otherwise, you can click on this save option as well. So it will also save it. Whatever you find it easy, you can do it. Clear, everyone?
Okay.
Perfect. So let's start for today. So I think everyone have joined. So I request everyone to open the PDF. So we had come up to this point, generating a model. So we will start with further assignment of the loads. Okay. So everyone just open the page number 10. So until yesterday we have seen up to model generation. Okay. So from here we will move forward as we would be doing some moving load aspects and also some design aspects. Okay, to check the plate modeling. Okay, so main purpose of this is to understand how the differences would be there, as what engineer Alosia has also mentioned about modeling in 2D and why we have to go with 3D. So that we would be seeing for today. Okay, so I hope everyone have come up to this particular point. Is everyone able to see the thickness view? Again, I have explained how to see the
Yes.
thickness. So here you can go in the hidden tab. There is a hidden option. You can just turn it on. If you're not able to see the thickness as this one, what you can do is you can just simply go to this options tab. Okay. So under the options tab, you will be able to see what exactly the options would be there. So here, display, there is a display option. Then you'll have to go to draw option. So if you're not able to see the thickness, only then you can see this particular step on PDF page number 9. Okay.
Okay.
So
Okay.
by default, it will be turned off. However, if you have to see the thickness, you go to draw. First of all, go to display under the view tab. Then there is a display option. Then there is a draw option. Then there is a hidden model view, the plane thickness, and the frame thickness has to be turned on. Okay. So that is a step. Then now we will move forward with this particular model. So now let's understand. So most of you could have already, I believe for bridge engineers who had already taken up these kinds of example to be done, like modeling a simple 2D box culvert. So again, in Midas, how benefits are there with the design aspects, we will be looking to for today. Okay. So now come to page number 11. So I request everyone to come to page number 11.
Please, which note are we using? Is this to the 2D cover boss covered?
It is 3D. Now we have finished yesterday with 2D. Now we'll be
3D was
yeah,
the
3D.
3D shared? Was it
So
shared?
yes, it's being shared. So I'll just if just refer to the group. Yesterday I have shared it. And also I have shared the model as well. So maybe you can just check it. So I have just put it in a group. Just refer to this tutorial. Okay. Yeah. I hope everyone have got this PDF. No problem. We are going slow by slow so that everyone is on board.
Okay, I've gotten it. I've gotten the
Okay,
PDF.
perfect. Okay, no
Thank you.
problem. Okay, so we'll follow from page number 11. So we'll continue from page number 11. So open page number 11. So yes, so what we would be doing is, see, what steps we are doing over here is simple. Let me repeat myself again. What we did have a recap for yesterday. It is something that we follow with respect to the steps of modeling, right? So first is defining the material. So we have seen yesterday how to define the material. So we just go to this properties tab, go to material tab and click on add, right? So based on the database, whatever you select, either the standard concrete or the steel, it will be taken up. Okay, so that is the first thing. Second thing is we have come up with this thing like after defining the material, now we want to create a geometry. So for creating a geometry, I have not discussed about manual part because it is something a kind of process where you have to manually create the nodes, elements, and again create a geometry. But however, in Midas, using the wizard, you will be able to better do it in a more easy way. So for that, we have used this particular box culvert wizard using a kind of approach where we have 2D box culvert and 3D box culvert, right? So based on that, the yesterday approach we have seen is with regard to the 2D. So again, today we are going to see with the 3D with the same example problem that we have done for 2D. Now, if you see the process of entering the data in wizard is something on the lines of first we define longitudinal, second we define as transverse, and third we define as loads, right? So that's a series of load we would be taking into a step process or a step manner to do with a geometry, right? So again, with entering this data, we have generated this particular model for now, where you can see there is a material, there is a set of thickness information, and also support which has generated. So in the tree menu, again, I have explained in tree menu how to see or visualize the loading or any position that you have to see. So let's say if I have to, let's understand about the working tree menu, how it works. So here, if you see, you can double click onto any of the tab. Let's say if I'm in a thickness tab, if I have to see where exactly it is being assigned, you can double click onto it and you can see it is being reflected over here. Same over here as well. So you can just simply double click and you can just see over here the thickness being
Hello? What song? I cannot hear anybody
Yeah, I
anymore.
cannot also hear or see the screen.
Yes. Actually,
Yeah, hello everyone. Sorry, I
your
think the line,
screen is not
the
displaying again. Your screen is not displaying again. Actually, what's wrong with your screen? Actually, sorry, gentlemen, just give us a little minute. It's like he's having little technical issue from his source. Actually, you're back
yeah,
online.
yes. I think it was reconnecting again. I'm not sure. Yes. So maybe let me share my screen again.
Just tell us you're sorry for wasting our time. Thank you.
Yeah. So yes, can you confirm if I am able to see the screen?
Yes. Yes.
Yeah.
Yes, we can
Okay.
see, we can hear.
All right. Perfect. So yeah. So I was explaining about this part regarding the activation of the elements. So as you see over here, we can activate the certain set of elements that you require to see into your model. That is through activation command. So you can just go to this activities, use this option, and you can also use this if you have to simply see the model again. Okay.
Can you come again, please?
Yeah, I'll repeat myself. So yes, the works tab, which probably you could have explored, right? So in the works tab, you can see all the model definition which you have done so far. So let's say if you have to see what are the type of elements that you have, you can double click onto it and you can see it into this particular model window being highlighted. Same, if there are multiple materials, you can also see, just double click onto it and only the elements which are assigned with the C30 would be visible. Same goes for the type of or like the thickness or the information of the elements or the sections that you are defining would be visible, right? So there are again the supports. So let's say if you have to see where are the exact supports being assigned, you can just over here make it display, elastic link, right? If you have, you can just right click and use this display option, right? So in this way, you'll be able to see what are all the type of supports being assigned. So again, for elastic link also you can see, and for different state of static load cases, right? Like the dead load and the other case of loads, you can just right click, make it display or undisplay. That is just for your reference to see. So you can just check into your model if you're able to, play around with the work step and if you're able to see and or display or undisplay these parameters. So this is useful when we have to actually verify our model if it's being defined or not. Even like at some point of time, you might encounter that, certain things are again duplicated. So how we are going to check that? So that is something that you can do it using the tree menu. Okay. Is this clear, everyone? This is the actual use where you can, make the things display and undisplay onto your model structure. Okay. So if you have to see the initial view, you can also come to this initial view option, and then you can just choose initial view command. So now let's move ahead. So yes, for now, what we would be doing is we would be doing the activation of the slab elements. So now why these steps? Because why I have explained this particular step is we would be assigning the loads onto our bridge structures. Okay. So here, what we would be doing is we would be assigning the loads. So let's say for onto the top slab elements. Okay. Refer to page number 11. We are doing the steps on page number 11. So I will just come to this view. So you can see, you can navigate. This is the Z axis, this is the Y axis, and this is the X axis, right? So if you have to see from the positive X, so you can just put it over here, okay? Or else you can come to this view. If you have see from the backside of the X axis, you can just click onto this command, right? So likewise, you can just use this XYZ navigation tab to rotate your model structure. Is this clear, everyone?
Okay.
The viewing? Okay, fine. Now, what we would be doing is we will activate our top slab elements. So here, I'll just go to this display option, or I'll just simply use this hidden option and using the selection command. So I just want everyone to see this, how we are going to select the top slab element. Again, using the select single option or select by window option also. You can just go to select by window. You can just drag a rectangle in this way. And you can just click onto this slab elements and you can just use this active option. Okay. So again, I'm repeating how we have done this because we don't want the assignment on any other element. So for easy reference, what we would be doing is we'll select the top slab element and make this as active. So this will allow only the top slab elements to be activated. Okay.
Okay, we have received.
Yeah.
Can
So
we
now,
do that, please?
yes, I'll do it for you again. So, like majorly when you're working with the model, what we would be doing is ideally we tend to activate only those elements which we have to work on. That becomes more easy for the assignment. So what I'm going to do, since I'm going to apply my load onto the top slab element, so I'm just going to activate only the top slab element. So how I'm going to do, I'll just come to this view, the X of negative. So in the negative X, that is the left view. I'll just scroll a bit and click once. So sometimes you might see the situation where, you are just clicked in and the model goes away, right? So what you can do, you can just click onto this part and you can get the model again. Okay. So you can press Control and the scroll option to rotate your model. So this is one thing, dynamic rotate option. Okay. And also, if you see, if you have to zoom in, you can zoom in using the only the scroll option. Okay. So this options enables to just simplify the model, or you just helps us to navigate the model in an easy way, right? So now what I'm going to do, since my moving load are going to get assigned onto top slab element, I'm going to activate only the top slab. So I'll just activate the top slab, use this active option. So I'll just go to this view tab, active activities. Under activities, you will see this active tab. So use active option. Okay. So now here you can see your slab would be activated. So you can come to the top view. So how to come to top view? You can use this Z vertical. You can just click onto this option so that the top view would be enabled. Okay. Now, what we would be doing as a next step is, since that we have come to top view, now we'll assign the moving load. So far we have much more had a discussion on the geometry generation. Now we'll see the load assignment, as we have also seen yesterday how to assign the static loads. However, today we'll see how to assign the moving load onto the plate elements or the shell elements. Okay. So just activate the top slab element. Then we'll go to the next step as loads. We'll come to loads, static loads. Then we'll come to moving load, right? Now
Actually, we are not hearing you again.
I believe the facilitator, his network is currently unstable, like he stated the last time he was logged out on the call. So please let's just exercise a little bit of patience. He'll be joining in a moment. Thank you.
Okay.
Also, while we are waiting for him to rejoin, please note that we'll be having a short break by 11 a.m. to take the keynote speech that was not taken before the session began.
Yeah, hello.
You're welcome back.
Yeah, hello, we're here.
I'm not sure, but there is frequent the outage. I'm not sure about it. But yeah, so I have just connected through my mobile now. I hope there wouldn't be an issue now. So yes, so let's start with moving load definition. So I'll be just just let me share my screen again. So yes, so I had been discussing about moving load. So for those who are following the PDF, please refer to page number 12. Please refer from page number 12 as we would be doing with the moving load analysis. So here come to load definition. So under the series of the load, as you can find, so there is a typical static load, temperature load, pre-stress load, moving load, and dynamic load definition, right? So we would be selecting moving load. So here select moving load, then select over here code as BS. Okay, so we will be applying BS codes for the application of the moving load. Now, everyone just have the attention how to apply the moving load as what is the general way into the analysis that we would be doing. Can anyone explain about the moving load? How we are doing typically? Like in any other software that you would be have been using, right? So majorly it is based on influence line method, right? Generally we calculate or apply the moving load onto the bridge and see what is the maximum envelope of the moving load envelope that we see for the given cases. As we can't directly determine using the static load approach, we generally give the more loads for the envelope cases. Envelope cases meaning is it just comes with the definition of the lane where it would calculate the effect of moving load based upon the influence line method, right? So you could have seen how influence line method works. So same has been integrated in Midas to calculate the most critical effect of the moving load approach, right? So here what we would be doing is we would first define the traffic line lane, right? So there are two options as you see over here. One is traffic line lane, which would be used when you are going to define the moving load onto the beam element. Now, as you say, there is a plate. So as you see, this plate element would take the surface lane definition. So here you can come to traffic surface lanes. Okay. So since it is being applied onto the plates, so it will be definition with respect to the surface. Now, when it comes to line lane definition, so it will be traffic line definitions, right? So that is the difference. So for now, since we are applying lanes definition onto the plate, so here you can go to surface lane definition, use traffic surface lane definition, click on add, and over here we would be giving the name as per the vehicle. So as you can see, this is a 3-step. What we would be doing is we need to define what is the lane definition, what is the surface lane definition. Okay, either of one should be the first step. Then next step is the vehicle. So here, if you see, there are the standard load models which are available as per the VS code, right? So you can run the HA vehicle, HB vehicle, right? Based on that, the load models are integrated, right? So you can just simply select the load model over here and automatically the load would be taken up. And also that as a next step, there are moving load cases, right? So this is the very third step to create the moving load case, right? So we would be going the application of moving load into 3 steps, right? So as you know, like why moving load? Because we need to work out what could be the critical effect. The worst effect, which is going to cause the maximum envelope of the hogging case, and also the maximum envelope of the sagging case, right? So both the critical cases needs to be worked out. Okay, so how we would be doing is, so very first step is assignment of the surface lane. So we'll go to traffic surface lane, click on add over here. Now I'm going to create a lane for HA vehicle. Okay. So I'll going to create a lane for HI vehicle where I'll just simply select the lane type as roadway. And also next step is lane width, wheel spacing, and the distance to be, I'm keeping the lane width to be as 3 meter, wheel spacing as 1 meter, offset distance to lane center is 0. So as you can see, offset into the diagram is A. So as of now, I'm going to give the lane at the mid location so that the offset distance becomes 0. However, if you have to assign the lane from any of the reference position, then you can just give the offset from the given reference position. So let's say if my reference position is going to be at the start, then let's say at a distance of 3 meter from the left of the traffic direction would be my offset distance. Okay. However, this, if you already know the distance, exact distance onto the bridge that you have to model, then you can just provide the distance at the offset point, right? Now, next definition comes is the start of skew angle and end of skew angle, right? So this start and end of skew angle is referring to the skew bridges. So in Midas, even you can run the moving load onto the skew bridges as well. The effect of the skew, right? So mostly like if you see, just a minute, I will explain how this works. So as you see over here, if you have bridges in skew, right? If this is a skew that you have modeled and your traffic direction in this way, right? So to the vertical, we would be having certain inclination, theta, right? So based on that, even to take care the effect of the longitudinal, I mean the moving load effect in the skew direction of the skew, we would be giving the angle of skew. Okay. So that is the advantage where you can enter the skew. Also for straight, we are not giving up over here any skew angle. So I'm just giving it as 0. Now, next step is to define the 2 points. So what it means by 2 points is something that is the direction of the traffic lane. Okay. So the direction of the traffic lane. So just a minute. Yeah. So what is the meaning of the traffic 2 points method? So for defining the reference lane, we have a type of 3 inputs. One is by 2 points, second one is by picking, third one is by number selection. So what are all these different ways to apply the moving load and in which case it would be applicable? I will explain that point. So 2 points. When we say 2 points, it is from start point to the end point. That to be in a straight line. It has to be in a straight line. That is the very first point. Okay, so now I'm going to use 2 point method only over here from first to last point. Okay, then I will click on apply. Okay, so if you see over here, yeah. So if you see over here, my this part, once I click on 2 points, there is a set of data which is generated under a table. Okay, so just understand I will be giving time for you to do this particular step. But however, the important is how the moving load assignment take place would be important. So here you just have to see that your node and offset data is created. Once this table is created, it means that the lane is now assigned. So you can see my HA lane now has been assigned. Okay, so this is the definition of lane. Okay, so let me repeat one more time. If you have to delete this, so you can see, you can just delete the data from here, tree menu. You can just simply delete. Okay. So the very first step is the assignment of the traffic line lane. So I have given the name as HA lane. Okay. Then I have given the lane width as 3 meter, wheel spacing as 1 meter, offset distance to the lane center is 0. And over here, there is a start skew and there is a end skew angle, right? Then there are 3 methods to input your 2 points or by picking or by number. So when we say 2 points, it will be first point and last point. Picking is something that if you have to assign the moving load onto the curved position, okay? Sometimes it might not be the case that your moving load would be in straight. However, onto the curved, if you have, you can pick the elements or the lane elements that we say to assign the moving load definition. Number. Third method is number. So number represents the assignment of the lanes to the given moving load definition. So let's say if you already have the definition of moving load, which is with respect to the element number. So as you see over here, if you can. So by number, what it means is the element number. So the node number over here as this case. So this has to be in order. So let's say if you have to assign from this particular lane. So the node number has to be in the order. So let's say from 2 to 13, if you simply renumber from 2 to 13, it will automatically get assigned. So it can even be on the curve, straight or skew. So that is the advantage of number method. But however, for straight, the most recommended method is using the 2 points. So wherein you can just simply select the first point as a reference and second point as the end reference where the lane needs to be assigned. Is this clear, everyone? The assignment of the traffic line lane. This is important when it comes to calculation of the moving load effect. So I'll explain what typically where we have to typically consider the effect of the
surface lane, right?
live load. Yeah, that's right. So now you can do it for now. You can assign the lanes. If you have any questions, please let me know. If you want me to repeat, I will repeat for you. So if you are referring the PDF, so make sure you are using the page number. Yeah. So let me open the PDF. So page number 12 we are doing, but however, if you see, the lanes are assigned as per the IRC vehicle in tutorial. However, if you want to do it using IRC, that's okay, you can do it. However, we are doing with the VS code. So I have taken the VS code as a reference. Okay. So even you can do it from IRC vehicle also as an example problem. Clear, everyone? Please do it now so that once you are done, then we'll move towards the second lane assignment. So in the similar way, we would be assigning for the second lane. So you can just come for HB vehicle as well. So you can come to load, traffic surface lane, click on add, and over here you can give for HB lane as well. So HB vehicle we would be considering. And over here, we are just giving with the eccentricity again. Just lane width as considering as 3 meter, wheel spacing as 1 meter, and there is no offset for now. So we'll be using the 2-point method right from the start to the end, and then we'll click on apply. So this is the lane for HB, right? So the HB lane we would be defining. Okay.
Okay. Excuse.
Can
Yeah.
you throw more light on this offset distance?
It-
And why is it negative?
Yes, this is the offset distance, right?
Yes.
You want me to explain how that works?
Yes. Can you explain it on the sketch? Okay, it's why is it
Okay.
negative? Is it the okay? I've seen.
It is onto the left or the right of traffic direction. So let's say
Okay.
if we have let me showcase to you how it works. So this is my center line, right? So if I'm going to define the eccentricity towards the left or the right of my traffic direction, right? So if you see, this is onto the left, moving towards this point. Let's say assume that my traffic direction is this, right? From left to right. This is x-axis, this is y, right? So in x-axis, if you see from start to end, This is my x-axis elemental local axis, which is from left to right. We are moving from this direction. Okay. So this is my negative, and towards the right hand side of the traffic direction, it will be positive eccentricity. So for an example, if I'm going to assign the reference lane from this position, so let's say from left. So this is xy, right? Now, if I input the distance as -3, so what will happen is if I take this as a reference, so from -3 meter, the lane assignment would take place. So as you can see, the lane assignment is exactly at a 3 meter reference from this position. Okay.
Okay, to the
What I
left.
mean, what I mean by that is the center line of the lane would be placed at a reference from this position onto the bridge.
On the left of the direction.
Yes, yes, yes.
Yeah.
So ideally, like most of the provisions in the code, as you see, are giving with the minimum distances of the placement of the vehicle from the edge reference,
Mm-hmm.
right? So for that,
Okay.
we need to calculate the exact eccentricity, and to place the vehicle in absence of the node or the line over there, we give the offset distance over here. That is much more easy way. Now, if you assign the same way from this direction, the eccentricity would come positive.
Positive.
So I'll
Okay.
just let me explain that part. So let's say if I'm going to assign from this part, if I say the positive one, okay, so now my traffic lane is going to lie onto the right
On
hand
the
side of
right.
my
On
traffic
the right.
direction. So that
Okay.
is going to be the positive direction of X, right?
Okay.
Is it clear? The negative and the positive
Yes.
direction?
Okay. So if you mistakenly put
Yeah.
if
Mm-hmm.
you mistakenly put the
Yes,
negative, I mean
yes. I
the
think
wrong, it will be an error.
yeah, that is very good question. So if you let's say if you have to edit it, the traffic line direction. So what you can do, you can select the table in one go over here. You can just use
Mm-hmm.
this option. See how I'm selecting. You can just click on this number so that the entire table is selected and press
Mm-hmm.
delete.
Okay.
So the lane data would be deleted, and also here from the tree menu, you will have to delete the name also so that the lane is deleted now. So that is the
Okay.
way to delete the set of data. Or if you have to change within the lane data, so let's say if you have already assigned and the lane, once you click on apply, it will get assigned. Unless you click on apply, the lane definition is not applied. Okay.
Okay.
So if you have to
Okay.
change it, you can change this intensity from this table also. Let's say if you have to move it to 4 meter, then you will have to copy this
Okay.
to every other table. So you can just see,
Okay.
you can
Okay.
just change this from, you can copy this and you can paste
Mm-hmm.
all the lane data over here. So that is something it is going to take internally. Okay.
Okay. Okay.
Is it clear, everyone? Please do it now. Two lanes. If you are following this, just simply define, and you know the purpose why we are defining, because we have to see the actual critical load placement of the vehicle, right? So for that, we would be doing with the placement of the lanes and the vehicle onto the bridge. So for just complete the first step of defining the traffic line direction, traffic line lanes.
So what does IF stroke CDA mean, please? Hello?
Yeah. Please go on.
Yeah, what does this IFCDA mean? I came across it here.
IFCD,
Stroke CDA.
in the lane definition you're talking?
It's in the table, yes. Although there is no data there.
Right. So you're not able to add the
You
data?
have node, you have offset distance, you have a span,
Yes.
you have
Yes.
IFCDA.
Okay. So by any chance
What does it mean?
you're defining in the traffic surface line lane. Make sure you're
Surface
not
lane.
defining
Surface lane.
surface surface lane only, right?
Yes.
Uh, so that is with respect to the impact factor that you have.
Okay, that's impact
IFCDA
factor.
is
Okay.
yes. However, if you see with the PS standard, for most of the vehicles that you would be defining, have the incorporation of the impact factor. Okay, so the
Okay.
loads are already factored as per the code. So here you
Okay.
can change the factor into the definition of the vehicle. But now, if you see with respect to the Indian vehicle, that the example problem that if you see this IF or the CDA, so it is referring to the impact factor or
Okay.
coefficient of dynamic augmentation. So it is
Okay.
referring to, yeah, so where
Okay.
we have to amplify the effect of the bridge. So you can't directly take the traffic load effect as such. So we need to sometimes amplify the effect and take
Hmm.
into consideration of into the design. So
Okay.
you is anyone aware of like this impact factor? Have you heard of impact factor? Why
Yes.
this
Hello,
has to be
please.
taken care? Yeah. Can
Yes.
anyone explain why we have
Hello,
to
please.
take care?
According to the dynamic effects of the wheels, of
Yes,
the wheel
yes, yes,
load.
that's right. Right. So that effect and also some accidental or effect that comes in has also be taken care using the impact factor, right? Even there are again multiple factors that we can consider using as an impact. Like there is a congestion factor sometimes in some of the codes that we have to consider. However, to account for the dynamic effects of the V, we are applying as CDA or the impact factor. Clear?
Excuse, please.
Yeah, please go on.
When I created it, I mistakenly created two. How can I delete one of it?
Yes, you can come to tree menu. So under the tree menu, you will see traffic surface lane definition. So let's say if by mistakenly if that is being assigned, right click onto that lane which are appearing in blue and press on delete option. Okay. So you will have to select that particular lane and click on delete option.
Thank you. Let me do
And you
that,
can
please.
reassign. Yeah. Thank you.
No, I've done that. I've deleted it.
All
So
right,
the question
perfect.
is, I created HLN and I saw in your screen that you have a HBLN created,
Okay. So we would be
right?
defining two lanes. So define two lanes. Once these are completed, then we will move towards the second definition of assignment of the vehicles. Okay. So we'll come to vehicles, click on add standard option over here. Click on add standard. And in the add standard option, you will have to select the standard HLA. So how to do that? You just have to click on apply. Same way for this particular part for HP. So you can just select from the drop down list for the HP vehicle. So you can see the load model. It's already integrated. So you can just simply click on OK, right? So HA and HB vehicle needs to be added. So it is just simply you'll have to select the vehicle and click on apply. So this is done up to this part. Then we'll move towards the next step. Once the vehicle are added, then we'll create the moving load. So now what you can see under the tree menu is the two traffic line lanes, surface lanes, sorry, defined for HAHP and also the standard vehicle which are defined as HAHP. Now remember, whatever appearing in blue under the tree menu is something not assigned into the model. Okay, so that we have to take care. Like if it is appearing in blue, it means that it is not assigned. Once it is in a black color, it means that the property or the parameters has already been assigned. Okay, so now we'll move towards the next step of creating the moving load cases. Now, as you see, we have created line lane. We have let the software know on which lane or where my traffic direction would be, and what are the vehicles that would run from this traffic line lane, and if there are any moving load cases, as in if there are any moving load cases to be defined. So you can just add it over here. Now we need to create the third step as moving load. Okay.
Excuse please.
Yeah. You're done with definition of.
Let me take you back a little bit.
Yeah, no problem.
In
Yeah.
this traffic surface lens,
Yeah.
in this traffic surface lens, we just created a one with name HLN, and
Yeah.
I saw in yours there are two, HA and HB.
Yes,
So
that's right.
we create the HB lens same way we created the HA lens.
That's right. That's right.
Okay, let me do that.
Yeah, sure.
While we wait and while before our facilitator continues, I would like us to quickly take the keynote speech, which was
Yes,
supposed to
sure.
have been taken before the session began.
Sure.
So, our keynote speaker, who is the Deputy National Chairman of Highway Division, Engineer Dr. Bola, is on the call. Engineer Dr. Bola Mudasiru, FNSC, FNICE. Please, over to you for the keynote speech, sir. Engineer Dr. Bola, is that you with us?
Engineer Nemot, the chairman, has extended his coming time to 11:20.
Thank you, Engineer Lawa. Yes.
All right.
He said we should
Thank you
give
very
him
much.
20 minutes. Yeah, thank you.
All right. Thank you, my chairman, Engineer Nimot Mwili, FNSC. Okay. Our facilitator, please you could continue. Thank you.
All right. So, yes, just continuing further. So we will move towards our next step of assignment of the moving load cases. So we'll come to moving load cases. Click on add. Then we will select the combination of the vehicle. So HA and HB. So I'll give the combination as HA, HB. Okay. Then I'll select the spatial load over here. Sorry, we will be assigning as per BD37. So make sure we have selected the class of vehicle as per the standard load. So it is BD37 code. Okay, so we'll be making the combination and the assessment as per BD37. Okay, so we'll go with the assignment of HA and HB. Okay, so here HA and HB lane. Now come to add inter subload cases. So under the subload cases, click on add. So just select HA and HB. So remove this auto light load combination option over here. And now when we are selecting HA, so just make sure you are selecting the number of loaded lanes as 1 and maximum number of loaded lane as 1. So here what we are doing is we need to combine the effect of both the vehicles. Okay. So as in, let's say if both the vehicles are simultaneously going to run, what would be the critical effect, right? So how to do that? Go to moving load cases definition, click on add, give the name as HA and HB lane. And after this, remove this auto live load combination as we are going to manually add the cases. Click on add. Now select HA lane and give the minimum and the maximum lane to be 1. And then click on apply. Similar way for HB lane, just select the HB lane when you are defining the HB vehicle. So just have to simply select the HB vehicle. Okay, over here also, make sure that you are selecting the appropriate lane and appropriate vehicle, right? So lane has to be selected. So meaning that whatever you have defined as lane, for same you need to define the vehicle.
Let's try and do that.
Yeah.
Akshay,
Yeah.
what's up?
Yeah. Hello. Hello.
Not hearing you. That's why I called. Continue.
Yeah. Yeah. Okay. We are just waiting for them to define. Yeah. Once defined, please let me know so that we can go forward. So if you are referring the PDF, please make sure we are on this particular page. However, the assignment is a little different for IRC. So you can just skip this and you can just follow what I have been doing. Okay.
Please, have you added the combined effect on a particular lane?
Yes. So what we are doing is we are just simply assigning the lane and the vehicle and its
Mhm.
combined or the independent effect. We can just select the effect as combined or independent. So what will happen is,
Okay, okay, I've seen
yes,
it.
yes, yes, we have seen this
Mhm.
option. So since we would be requiring to obtain the loading effect as a combined,
Mhm.
so it
Mhm.
will consider both the vehicle placement to be
Mhm.
done at a one point.
Okay,
Yeah,
okay, okay.
yes.
Hello.
Yeah, hi.
Okay, sorry, I know I'm late, I'm far behind, but I just want to ask this question. Um, why putting in my property? After put plotting in all the property materials and I'm to click OK, the drop down box is not allowing me to get to where I will click OK. If I look,
Can you just change the resolution? Can you change the resolution over here?
okay,
You can go to display settings.
okay, oh, like
So
that.
yeah, change the resolution scale, either to recommended or just change to some lower settings.
That means I have to close this area data.
Otherwise, what you can do, the second option is just check
Okay,
if you are able to see just by using this option. So go to material properties, click on add. There is small cursor, I mean small minimize option left to the concrete. So if you click onto that so that you will be able to see the OK tag. If
okay.
if if you are still not able to see, then change the resolution. This is the first step that you do.
Uh, sorry, come again. Said the material property that close to concrete. That should, I will see
Yeah,
what.
there is a minimize option. You can see a small minimize option left to the concrete.
Okay, let me look up. Let me look for it. Nice option. Nice option. Uh, I can't see that. It's not there.
It's still not there. Then you can use the
It should be
resolution
there.
settings to change. Yeah,
Okay, so
yeah.
I have to go back to.
No, you can just minimize that. That's fine. You don't have to close it.
I know as I close the property. I don't know where will I see the minimize.
Sorry.
Where will I see find that the minimize option?
Uh, okay. So is it able you are able to do using the display command? I mean display option settings.
Mm, yes, yes, yes.
So can you go to display settings and change this scale to 100% maybe? Yeah.
Okay. Uh, no, I can't find that display option setting.
Which one?
I can't find the display option setting. Where should I go to? Is it project or properties or
Yeah, right click on display settings, and over here there is a scale.
okay, sorry, I'm not seeing what you're doing. Let me just go to where you are. Oh, then display.
right? You are able to see the scale option.
No,
Okay. Display settings, right? You are under display settings tab.
no, I've not seen that display setting. That's
Okay. Can you just come to display settings tab? You can just minimize and onto the screen. You're able to see this, right? What I'm doing the steps.
yes, I'm seeing your record. Nothing is showing yet.
Okay. Maybe like just if you're not able to do, we can do it during the
Later.
break. Yeah, you can just what you can do if you're not seeing the OK tab. As of now, what you do, just go to tables tab. Go to tables tab. Okay.
Mm,
So
okay.
under that, you will find the properties option and add material over here. So click on material and using the tabular format, just add the material. How to add that? Just select the standard as what we have doing. Then select the type of material and from the database, you can just simply choose what you have to define. Okay.
Okay. Let me try that. Thank you.
Yeah, please. Yeah, no problem. So yes, now coming to the moving load case. So let me have a recap what we have done for moving load. Remember, for any bridge to be modeled, the moving load procedure is going to remain same. Okay. So this is the main thing that we have to understand when we are going to define the moving load lanes or the moving line lanes. We have to first let the software know what is the typical placement of the vehicle lane. Second, what are all the standard vehicles that we have? And if we have to run as a moving load case, right? So that we have to simply do it over here.
Excuse me. Excuse me, please. Hello, Mr. Akshay.
So use this activate all to
Okay.
get your structure back once we are done with definition of the moving load.
Excuse me, Mr. Akshay.
Yeah, it's done.
Yes, Donny, but for clarity, I want to understand
Yes,
that
yes, please.
you use traffic line lanes on like a beam and slab kind of structure.
Right,
Then traffic surface lanes on slabbed bridges, for instance,
right,
or
right.
covers like this. Okay. All right.
Yes, yes,
Okay.
that's right. So wherever we have a surface element like plate or shell, we need to go with the surface lane definition.
Okay.
Wherever we have the traffic beam elements, like particularly when we have to effect as the influence line method based on the line approach.
Yeah,
So
okay.
that case where we have beam model, we will be defining using the traffic line lines.
Okay.
Yeah.
Hello, Mr. Ashe.
Yeah. Hi.
Yeah, sorry, I was a little bit late for today's session. I wanted to
Okay.
ask a question which I think you have passed the stage, which is HA and HP loading. Number one,
Right.
what are these HA and HP loadings? And are they important on a culvert? Because most of these culvert, they are not kind of on the highway
Yes.
mostly maybe on the rural roads. Do you still need the HA and a HB loading just like in bridge? And what is the meaning of the HA and HB loading,
These are the standard
please?
vehicle loads, sir. This is as per the code. So it
Okay,
is something the load model which is defined as per the code, as per the BS standard. So they have their standard loading. What we can say is that this is a particular load model which have been, based on certain studies and the case preparations. They have come up with the loading for moving load definition, where we can see
okay,
the values of the loads as given this point to analyze. So this is the code part. This is what it is given into the code.
okay, sir.
Yeah.
Thank you.
I think for more clarity, I think the HA loading is representing the UDL component of the load on the bridge, right?
Yes, 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 yes. As you can see, the intensity of
Okay,
the load is
okay,
over here. W is per unit length, right?
okay.
So which is
While the HB
0.67.
loading,
Yeah, yeah,
while the HB loading is referring to the vehicle,
that's right. Yeah.
the
So it is
design
point
vehicular
one.
load. Yes,
Yes,
exactly.
yes, that's right.
Okay, okay, I get it. All right. Thank you.
Yeah, thank you. So now let's move ahead with the next part. So everyone, I hope you have got this moving load definition. Okay. So now we will more focus on the design aspects. There are certain design parts that we have to do it. Okay. So I'll explain that. So now here come to page number 16. So everyone just come to page number 16. So here what we would be doing is we would be creating the model, or we would be dividing the model into domains and subdomains. Now, what is this concept? For the design part, we would be requiring, or we would be fixing the reinforcement direction. Okay. For the calculation of the forces and the stresses into the member. All right. So for that, we would be fixing what would be the main direction and what would be the sub rebar direction. Okay. So for that, we would be defining the domains. So what is this concept of domain? So let's say if you have the entire slab in which there would be certain change of reinforcement. So maybe with respect to the requirements. So what we can do is we can accordingly define or let program to calculate or design as per the given domains and subdomains. All right. So let's say if I have to design the top slab or the bottom slab. So accordingly, based upon the demand requirements, the design would take place into the software. All right. So let's see how we will be doing. So I have explained why we have to do it, and now we'll see how we need to do it with these steps. All right. So let's go to the model generation. So come to page number 16. If you are seeing this, come to page number 16, in which we will be seeing how to activate the domain segment and subdomain segment. Again, subdomain is something that, let's say, if I have to explain in more better way. Okay, so let's say if you have a complete slab, right? So this is my complete slab. Let's say, for example, this is the top view which you are seeing it, right? So what you can do is you can, since it is divided, right? So it is divided into different elements. So what you can do is you can just divide the section into different verticals. So let's say maybe it could be the end section of the slab, or it could be the d/2 distance, or it could be the mid of the slab, right? So let's say this is d1, d2. I am naming in this way, right? d3, d4, right? And this is d5, which is mid fur, right? So based on that, what you can do, you can simply categorize or cut your slab into different divisions for the design purposes. Now, why we are doing is we are just allowing software to calculate the end section for the consideration of the this only demand, right? Whatever the demand would be there, as we know that plate elements, we would be getting the forces and the stresses into the local direction. So we will be obtaining for this particular zone the different requirements of the moment demand or the the force demand that would come up. So for that reason, we would be separating it as a domain. Let's say this D1 and D2 is the entire domain over here, right? So this I will categorize as domain. In again, like if there is a change of reinforcement or there is a kind of new reinforcement to be adopted over in this particular case for this zone, for let's say for an example for D2. So what you can do within the domain, you can create the subdomain as well for the similar case requirement, right? This is subdomain. So it is going to basically take care or design your entire slab elements as considering the demand for the elements of force demand which is coming up for the elements which are categorized as domain and subdomain. So what we need to do here is we need to fix what would be the direction of main rebar and sub rebar. Okay. So this is the rebar definition that we have to do. So first, like we will be fixing our main rebar direction to be placed in this one and sub rebar to be placed in this one, as the major bending would be along this particular plane, right? So the major bending would take place along this plane. So my main direction of the reinforcement would take place into the x-axis. So if I see this is the axis, this is xy. So my x would be the main reinforcement direction. And for sub rebar, it will be placed in this direction, right? So this y is my sub rebar direction. Is this clear, everyone? What we need to do as when we design manually and when we are going to do it in a software, how typically the differences comes in and how we are going to define using the domain and the subdomain option. Please let me know if I have to explain this part again. Otherwise, we will move towards definition into the software to
Yeah, please
output.
again,
Yeah,
again. I want to
yeah,
understand that domain.
yeah. So domain, again, as I said, your slab as a whole is divided into a lot of small elements which are discretized as plate elements. Correct? Now, what we would be doing is instead of designing a single slab as a whole 1D beam element, okay. So what we are doing over here is based upon the requirement of the zones, like for maybe for different demands for the end portion or the mid portion, we are going to categorize the entire slab element into one. You can even make the entire slab into one domain and rest of the region, let's say the mid region or the end region into subdomains. Even that is also okay. All right. So this will just assign the placement of your vehicle because like sometimes there could be different arrangement of the given reinforcement. Maybe the rebar direction would be something different for this domain or the other part of the slab. So remember, domain is nothing but the part of slab that you are going to categorize for the calculation of the design forces. maybe like once we are going with the design part, maybe it will be much more clear once we proceed further. So I'll explain why this is important. And particularly when we see the results of the slab detail, we would be able to further cross-check what is the significance of this creating the domain and subdomain.
Okay. Okay. Can go
Clear?
ahead.
All right, thank you.
All right.
All right.
Um,
Yeah.
Thank you very much, our facilitator. So our keynote speaker is now available. So I would like to call on the keynote speaker, Engineer Dr. Bola Mudasiru, FNSC, who is the Deputy National Chairman of the Nigerian Institute Division in Nigeria. Engineer Dr. Bola.
Yes, I can hear you.
Yes. Please, over to you, sir, for your keynote speech. Thank you very much, sir.
Okay. Do you want me to share a slide? Okay, don't worry. Maybe I'll just read from here. It's fine?
Okay.
Okay. All right. Thank you very much. Once again, good morning, the chairman of NSC Ikeja branch, and to every participant on the call, whether physically at NSC Ikeja hall or you're joining virtually. The leadership of Midas Solution, my fellow engineers, colleagues and professionals, ladies and gentlemen. It is an honor and a profound privilege to stand virtually before you today on day 3 of this pivotal workshop. I bring you warm fraternal greetings from the entire executive and membership of the Nigerian Institute of Highway and Transportation Engineers. We are deeply appreciative to the NSC Ikeja branch for this strategic invitation to collaborate. We also commend the foresight and vision that birthed this partnership with Midas Solutions, recognizing that such alliances are the bedrock of engineering advancement in our time. When I look at the calendar and see May 2026, I am reminded that the future we used to discuss in theoretical terms is now our urgent and present reality. The global engineering landscape is shifting beneath our feet. The transition from traditional method to digital ecosystems is no longer optional. It is inevitable. We are gathered here not just as participants, but as beneficiaries of a monumental shift. If we recall, in October 2025 precisely, the Nigerian Society of Engineers launched a landmark partnership with Midas IT, India. And this collaboration, when was checked, it was valued about 17.4 million USD. And this is a watershed moment for our nation. This initiative has facilitated the donation of essential Midas software packages, including Midas Civil, Midas Gen, and Midas GTS NX, to not only engineers, but even to Nigeria universities. And if we recall also, speaking on this transformative partnership, the immediate past president, Engineer Margaret Aina Ogutala FNSC, expressed profound appreciation for Midas IT's generosity. Of course, highlighting its alignment with NS's mission to foster technical innovation and improve the quality of engineering education in Nigeria. It's also very much important to state that this workshop is a direct extension of that vision. It bridge the gap between the software now available in universities and also the practical and high-stake demands of the industry. Today, our focus is on the application of Midas software solutions, and I want to challenge us to view Midas not merely as a software, but as a force multiplier for the Nigerian engineer. Whether we are discussing bridge design or building structural design, the law of physics remain constant, but our capacity to analyze and optimize them has evolved exponentially. When you look at bridges like Midas Civil, it's a tool that empowers us to model complex geometrics and analyze dynamic loadings from heavy vehicular traffic to seismic activities with a granularity that ensures our public infrastructure stand the test of time. Now for buildings, Midas Gen also push the boundary for actual creativity while maintaining the strictest safety standard. In an economy where material costs are volatile, it helps us to optimize material usage, drastically helping to reduce waste. Of course, if you're in geotechnics, Midas GTS NX and helps to analyze such structural interaction with advanced finite element methods, ensuring our foundations are as robust as the superstructure they support. Now, from the perspective of highway and transportation engineer, we understand that the structural integrity of a bridge is not a matter of statistics. It's a difference between life and death. This workshop is important because it directly addresses the skill gaps that often exist between the academic theory and the complex, unforgiving demand for modern industrial projects. We at the Nigerian Institute of Highway and Transportation Engineer believe that for Nigeria to truly leapfrog into the next tier of infrastructure development, we must master these digital tools. We cannot build a 21st century economy using 20th century design methods. The over 17 million USD investment by NSC and Midas IT provides this hardware and software. This workshop provides the human way, the expertise to weave them. To everyone participating, both here virtually and also maybe the training hall now, and those joining us wherever they are across the globe. Like currently, I'm speaking from FIDIC Africa in Accra. I want to say this charge in threefold for you today. One is that let's engage deeply. Do not just learn which buttons to click. Understand the engineering principles behind those algorithms. Let the software sharpen your engineering intuition, not replace them, please. And be a master of two, not a servant to it. The second charge is to collaborate. Look to your left and right. Some of the best innovations in our industry will come not from the podium, but from the conversation you have during the breaks, networking section. Share your challenges and share also the solutions. The third charge is knowledge without application is merely potential. Take these skills back to your offices. Apply them to real Nigerian projects. Let us see the output of this workshop in the quality of the foundation we lay and the structures we raise. I conclude by saying this, that a special thanks to NSC Ikeja branch led by my sister, Engineer Naimont Moili, FNSC, FNICE, for this wonderful program, and also to our wonderful partner, Midas Solutions, for organizing this hybrid format, ensuring that geography is no longer a barrier to knowledge. I urge all participant institutions, individuals, professional bodies to continue supporting such initiatives, for they are the engines of our collective growth. Let us embrace this technology, not as a foreign imposition, but as a necessary indigenous tool in our hands. Tools that will lead to build a safer, smarter, and a more resilient Nigeria. Thank you, and I wish you a most fruitful rest part of this workshop. God bless NSC Ikeja branch. God bless Nigeria. Thank you very much.
Thank you very much, Engineer Dr. Bola Mudarisu, FNSCF Nice, for the wonderful key notes speech. And thank you for joining us all the way from Accra, Ghana. Thank you very much, sir. We will just move right in back into the training. Our facilitator, Aske, can you please go on with the training? Thank you.
Yeah. Yes, thank you. I appreciate the keynote speakers, message to all the engineers in Nigeria, as what we would be strategically building with the partnership, as they have correctly mentioned about being, the importance of the technology in today's world that we have to adopt. And again, we thank for this opportunity to Dr. Bola and also the NSC branch Ikeja, where we have been, effectively be able to conduct this particular workshop from behalf of Midas. Thank you. So let's continue from here. So yeah, we have come up to the definition of the lanes. Now we would be doing with the explanation of, the domains and creating the subdomains, right? So if you have to undisplay the lanes, you can just go back to the tree menu, right click, make it display and undisplay. All right. So this is the one thing that you can do it to visualize your lane definition onto the bridge. Okay. So if you are still not able to see the resolution, so maybe what you can do, you can go to this display settings, and in this you can just reduce the scale to 100%, or maybe, a recommended one. So if you are already in a recommended settings, you can go back and you can set this to 100%, and then you can just come up at this particular point to see if you are able to see it in or not. Just check if you're able to see the OK tab or not. If not, for now, what you can do, you can define it through the table definition. So tables are something that again would be useful when you're defining through the just the approach of selecting from the table, just from the drop down list. So in table, you'll be getting this kinds of drop down list to select. All right. So here you can just simply select the code, the standard, and the grade of concrete required. All right. So now moving height. So now we will be creating. So everyone just we have this PDF. So come to page number 60. Come to page number 16. We'll start from page number 16, creating this domains and subdomains. Okay. So now what we would be doing is we'll go to this front view and we'll select only this particular elements to categorize into subdomains and subdomains. Okay. So how to do that, I'll explain. Page number 16, everyone, we are following now. Okay. So come to page number 16 of the PDF where we can see there is a domain for slab. Okay. So come to node element tab. And over here, you can find there is a kind of domain option over here. So click on domain. Use define domain option. Okay. So here we will be giving the name as slab. Maybe you can categorize as top slab or bottom slab as required. Now we will have to select the element. So how to select the element over here? You can use the select single option. So here you can come to this view tab, selection tab, and you can simply select the top slab elements and bottom slab elements. So once sooner you select the top and bottom slab selection in this way, you can see the list would be automatically updated over here. Okay. So again, I will explain how to do that. come to this particular domain option. So under the node element tab, so there is a domain. So use define domain. Here, give the name as slab. Now we need to update the element list. So we just select the top slab elements and bottom slab elements as slab. And then click on add. All right. So once you select the top and bottom slab element, click on add. So we are doing these steps on page number 16, everyone, those who are referring the PDF. So do this step, and also we need to create the side walls also. We have to create a separate domain for side walls. So again, we would be adding for side walls as well. So in this case, we have to select these walls over here and we have to add it. So two main domains we have to add, which is slabs, which is covering the both top and bottom slab, and side walls, which are covering this side walls.
Okay, can we do that, please?
Sorry, you want me to repeat?
No. Can we do that? Can we just do what you did?
Yeah. Please, I will wait. No problem. Yeah. Is this completed so that we'll take up the next step?
Yes.
All right. Now we would be going with the activation of the slab elements. Again, as I said, like for the domain and the subdomain, we would be categorizing again with the subdomain. Let's say for end slab, the left slab, the mid slab, right? The portion. So for that, what we would be doing is we'll just simply activate the top and the bottom slab. Okay. So you know how to activate the top and bottom slab. Just select using the select single option. Just drag a rectangle onto the top slab. And over here, just drag the rectangle onto the bottom slab. Then you just go to this view command, use this active option. All right. And now we would be categorizing within the slab the different domains. So we can just select over here, use subdomain option. Okay. So first of all, what you do, just activate the slab once you define the domain. Okay, so I'm just repeating one more time. Just select the slab in this way. Go to active, use this active command so that the top and the bottom slab would be activated. And further, we would now be defining the subdomain. So come to node element tab, go to this domain option, use define subdomain. So here we have to select which subdomain we would be creating. Okay, so define until this point. So once we select this particular part, now here if you see onto the PDF, we would be categorizing in different subdomains. So let's say we would be defining the left-hand slab. So how to select that? So we will give the name as left end slab. So make sure it has to be under the category of slab only. Okay, not the side walls, because we are defining subdomains within the top and bottom slab portion. Clear? Select the member type as 1D. Okay. Select the member type as 1D, and over here select the direction of the rebar in the local direction. Okay. So by default, it will take the main direction to the 90 degree. I mean, in the 0 degree, sorry, and sub rebar in 90 degree. Okay. So the rebar direction we can fix. And further, we would be selecting the list of the slab element for the left hand. Okay. So in this way, we'll be selecting the left hand slab. So this is left hand. So we are referring to this as left hand. And then after that, click on add. Okay. In the same way, we have to consider it for the right hand slab definition also. Okay. In the same domain only. Okay. It has to be right hand slab. So select this. And click on add. And also third is the definition of mid slab element. Okay. So the mid slab element we would be adding. So under the same category of rest, all the definitions would be same. Now we just have to add the mid slab portion. Okay. So click on add. So in this way, we have to simply do the right hand slab definition, the right hand, left hand slab definition, and the mid slab portion. Okay.
Yeah, okay, thank you.
Yeah.
Please, sorry, can you come from the beginning where you select the definition of
Yes.
subdomain?
Yes. Okay. No problem. So I'll just close this. So activate the top slab and the bottom slab element, right? After that, come to node
Yes.
element tab. So under that, you will find the domain option. So use this define subdomain option. Okay. And under this, make sure that you are selecting the slab, just because we are referring to top slab and bottom slab element. And also your name. So name as in the name for the domain. So let's say we are differing from left hand slab. So select left hand slab elements. Okay. Select the member type to be plate beam 1D. Okay. Select the member type as plate beam 1D. After that, select the rebar direction to be local. And once you select the rebar direction, after that, just select the element list as left slab element. Okay. Just select this as left slab element over here. And then click on add.
Excuse me, please.
Is this clear? Yeah, yeah.
Yes. Can we unhide this structure? I want us to relate these
Yes.
elements you've selected to
Uh-huh.
the actual structure, why it has to be so. So if you
Sorry,
can,
sorry.
if you can unhide and bring out the full cross section again.
Yes, 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 yes.
Okay.
So you can come to view tab. You can use this active,
Active
or you
all or
can
something.
deactive all. Yeah. So yes.
Okay. Then
So
on height, let's see the thickness, please.
yeah, yeah, sure.
Okay. So these elements are the corners. I believe these are the elements we're referring to.
Yes. So these
Okay.
are left hand slab element. These are
Okay.
mid slab,
Okay.
and these are right hand slab elements.
Okay.
Yes, yes.
Okay. All right then.
Yeah, perfect.
Mhm.
Okay, so once this is done, let's move ahead with the same definition of defining through the sidewalls. Okay, so if you are referring this, please come to page number 21 of the PDF. In the similar way, we would be defining the subdomains and main domain for sidewalls. We have already defined the main domain. We just have to define the sidewalls. So again, the procedure remains the same. What we have to do is we'll just have to come at this point, select the sidewalls, and you just click on active so that we will be able to assign it in more clear way. And you can use this X side view to define for top side walls, end side walls, and mid side walls. Okay, so likewise we will be defining. So the top walls, again, go to definition of node and element. Under that, define subdomain. Now here what you have to do is you will have to select the side walls. Okay, just select the side walls, use the plate. Now we will be giving the name as per this. So top walls, so let's say top wall elements. Okay, now the member type here would be column. So this would be designed, your wall would be designed as a column elements. So select plate columns. Now the direction, rest of the definition would be similar as main direction would be local. Then this would be the element list. Then you can simply select this using the selection option. So go to select by window. Okay. So select the top wall elements. So now if you see when you select from any of the view in this way, the elements whatever in that particular plane will get selected. So that is the advantage of selecting in this way. So once you select in this way, like even whatever the element in the defined plane would get selected. So if you see, the elements are quite far, but however, it is lying in the same plane. So it will get selected, right? So I'll just press escape. To deselect this particular element, what we have to do is we just have to simply press escape. Okay. Now this is the top slab element. And then you just have to click on add. All right. Now, same way for mid walls also we have to do the similar things. Main domain would remain the same. Only the subdomain we are changing it over here. Okay. Please make sure that it has to be uh, mid walls. Okay. Main subdomain would remain the same. Now we are going to select the side walls and just click on add. And same way we have to add it for the end walls. Okay. Bottom walls we can say. So just complete until this part, then we will move towards the analysis steps. Okay, so we have almost done with the definition of moving load, creating a 3D model, and definition of the loads, right? And we have done a certain first step of design definition where we have just uh, defines the domain and subdomain. All right. So complete
Okay,
until
let's
this
try and
part.
do what you did.
Yeah, yeah, sure. We'll wait. Is it done? So shall we move ahead with the analysis part? Please let me know if completed. So you can see the domain definition into the works tab. Like there is a left hand, it's a mid slab, there is a right hand, right? So even for the bottom slab, you can just cross verify. If by mistakenly, if you have done or assignment wrong, you can just go to properties, and again you can just select the element and make it add. Okay. So it will automatically replace the element. So yeah, I hope it is done. So let's further go ahead with the next steps. So come to page number 24. We are coming to page number 24 now. So here further, we would be doing certain step for the analysis. So we have completed almost the geometry and the loading definition. So come to analysis part. In the analysis tab, we would be looking for the definition with respect to the assignment of certain moving load functions, or if you have already defined with some stage or something. So those control, you can do it in analysis tab. Okay. So now let me showcase how we will be doing this. So here we just have to go to moving load, and over here, since it's a influence line method, as you see on page number of 24 of the PDF. So what we have to do is we just have to simply select the parameters over here, but by default it is turned on. So let's say it might be the case that you would be requiring both normal plus concurrent forces. So you can simply select it from here, and also you can use the calculation filters. So now these calculation filters are nothing but your results to get for a specific groups or the construction group. It is not relevant at this point, so just ignore this particular part. Just go to analysis control option and click OK. Okay. Next part would be here. Once you define the construction stage analysis control, now just go to perform analysis and use perform analysis option. Okay. Go to analysis and use perform analysis option. Hello?
Hello, can you hear me, please?
Yeah, I can hear you. Yes.
Yeah, please, can you come back a little?
Okay. Yeah, where you have left? So we were here until this part of analysis. You reached up to analysis part?
Yes, yes.
Okay, perfect. Come to moving load. So under moving load, here we are having this just the set of control for moving load analysis result output. You can simply, as of now, it is by default what we need is both concurrent forces and the normal forces for the output, and the calculation filters can be applied. Okay.
Yeah,
Okay.
I'm with you.
Yeah. All right.
Let me try and do it.
Yeah. Please.
After doing this and pressing OK,
Yeah.
nothing happens.
Yeah. Then it will automatically perform the analysis.
Okay.
Yeah. Also, for those who are not able to get the exact model, I mean, like those who have missed out the definition, you can open the model which is being, shared earlier into the group. You can just refer to that model as well. Okay. I have already shared this particular model in a group. You can just open that model as well if you want. So just check if you're able to analyze. Just let me run the model.
Okay, after doing what you just showed us, I
Yeah.
click OK, and nothing happens. Is that the normal?
No, there will be like just a minute. I'll explain to
Don't
you.
get you pardon.
So see over here, once you click on analyze, there will be two aspects. So you will be redirected to post-processing mode. Okay. So what we called it as a post-processing mode. Okay. So yeah. So here if you see, this is pre-processing. Are you able to see this? This is pre-processing mode and this is the actual post-processing mode. Once you click on analyze, okay. So once you click on perform analysis, you'll be redirected to post-processing mode. Okay. So once you perform the analysis, you will be getting to the post-processing, meaning that you won't be able to change or define any of the property over there. I mean, once you have to, the model will be locked for seeing with the results. Okay. So just let me see this. Just first place.
So we are going to perform analysis now.
Yes, that's right. So let me free up some space in my system. Oh, that is okay. Just so are you able to perform the analysis like whether it is displaying this message at the bottom that you will be able to successfully analyze the model? Just check if you are able to do it. Are you able to see the message that you will be able to successfully run the model? Your job has been, successfully completed. If you're able to see that message, then it means that you would be able to, run it successfully. Just let me.
Yes, we are able to.
So I'm just freeing up some space.
The Midas job is successfully complete.
Okay, okay, okay. Just give me a minute. I'm just freeing up some space. I guess my C drive has uh like just- So yes, once you are done with the analysis, I'll just share my screen. Sorry, there was some misconnection. Dear host, can you just allow me to share the screen? Hello? Hello?
Hello, we are with you.
Yeah, yeah, yeah. So, dear host, like, can you allow me to
Can go
share the
ahead and
screen?
share. Yeah.
Yeah, yeah, yeah. Yeah, still I can't share.
for the continent.
Admin should kindly assist Abse, please.
Seen as dominating to.
Hi, so you are currently the um engineer Abdullah Zubair. You're currently the host as the network had dropped me off, so now you're currently the host. So please make the facilitator a co-host and myself as well so that he could be able to share his screen. Engineer Abdullah Zubair, can you hear me?
Yes, I can hear you. I'm trying to do
All right, thank you.
make you a host, and your name is okay. Make you a host. You are the host now. Oluwatoyin, you are now the host.
All right. Yeah, thank you. I've made him the co-host. Our facilitator. Thank you. Please, can you go ahead and share your screen?
Yeah, thank you. Now I can share the screen. So now if you see, yeah, thank you. If you see now, once you analyze the message, you can see in this analysis window tab, okay? You can, there are two tabs. One is command. Once you click over here, there is analysis and command message. What is the meaning of this is once you click onto it, you will see this actually. So here you can see there is a command. Once you click, you will see analysis message. So in analysis message, whatever the errors that are being, showcased or maybe, they are being encountered during the analysis will be shown over here. And command message, whatever before the pre-processing, like if there is no assignment of certain support or load, if something has been missing, those will be shown under the command messages. When you are actually modeling the structure, at that point, it will show up in the command message. However, in analysis message, you can check what are the errors that have been done. If you are getting this message, that it means that you have done there are no errors into the model and the model is correct. Okay. So now let's come to the next part, which is seeing up with the results. So now as we have seen, we will be going to the results tab. Let me hide this. So come to analysis tab. Under the analysis tab, we will be seeing with the analysis results. So in this, we have the reactions. So you can check the reactions over here. So for dead load, you can turn on what are the values and the legend. Click on apply. So you'll be able to see, you can just turn off this particular hidden window. So here you can see what is the reactions that you're getting. So what is the maximum reaction and summation. If you have to check, you can always refer to the result table. Okay. Yes, Engineer Adekoya.
Hello, can you hear me? Good afternoon.
Good afternoon, sir.
Yes, sir. So I've gotten to this point, but when I want to run my analysis, I did try running the analysis, but I was getting error messages. So I don't know where it came from. Probably I'll have to take some step back again.
Okay. Can you just check the error messages if you are getting some kind of boundary support? There will be the actual, the error which would be displayed. Maybe it could be some node should be abnormal or, there's a sort of analysis warnings. You're getting warnings or you're getting error.
Okay, I think I will go through the design again and see where the error came from.
Yes, maybe 90% it would be the definition of support, or maybe you could have missed out defining some parameters. Maybe there is just the geometry, there are no supports. Maybe how to check that I will explain. You can just go to this works tab and just check if you have assigned material, thickness, support has been there. You can right click and make sure that supports are there. Sometimes what happens if the supports are not defined, the model would give you the several warnings and it would not be analyzed. Okay. If there is some
Okay.
point, the warning showing up abnormal support conditions, then we need to check that if the loading has been defined in a correct unit definition. Sometimes the load magnitude which we would be defining would be way more higher than the actual load applied. Okay. So we have to make sure that the loading definition and the unit system which is adopted is correct. Clear?
Fine. But I think I would need guidance on how to check the loading and the supportive there. Then.
Yes, that's perfect. Yeah.
By 12:30, we'll be proceeding for break. I'll resume back by 1:30. 1 hour break for prayer, stretching of legs, eating, and other things. Thank you.
Okay. So, all right. So we are moving towards the results. So for those who are not able to get the analysis done, maybe they can refer the original model which is being sent for now. Then further we can connect during the break to resolve your errors, and I will explain how we can do that. Okay. Apart from the checking of the results with regard to model, like definition of support, correct load definition is being done or not. So those we have to check it. So now let's move ahead with the definition of, checking with the results. So if you have to see the results, you can come to analysis results over here, come to analysis results, then reactions. Okay, you can click on apply. Now deformations also you can see, you can come to displacement contour and you can see the deformed shape of the structure. So as you see, the dead load deformation would be in this way. So this is the dead load deformation as you see. You can turn on the value. Value is something that it will be displayed. What is the value of each node for deformation onto the model? And legend. Legend is something that it will show up with regard to the right hand side with the color coding as red, green and blue, right? So here you can see whatever the red is maximum deformation that you are expecting to the minimum, right? So it will be shown in this particular range.
It is to you all, as of now, we can call it a break and resume back by 1:30. We go for prayer, eat, stretch your legs, relax, refresh, and return. Thank you. Thank you.
Yeah, I think I lost the connection. So for now, we will be waiting for a break. Okay. So we'll resume our training from 1:30. Thank you, everyone. We had been discussing about the results. So how to check with, so ultimately what we need as a result, when we say result, what is actually the result, what we are going to take from the model, how to extract the design forces. So this is a kind of important where we have to look upon the specific results for a given combination, right? So how you generally design is not for a particular load case. So rather it is more towards what we say is the load combination, right? So again, like as you say, we have discussed about how typically to form the load combinations, right? So if you go to load combinations over here, if you go to concrete, so you can obtain the given specific load combination using auto generation or manually inputting the load cases, right? So how you would be doing is you can go to auto generation over here. You can select the design code, right? So here in the design code, you can select the specific code. Let's say if you have selecting with BS code, accordingly, the BS code combinations would be enabled, right? So as of now, as you can see, since we have selected the code, you can see onto the left hand side, there are the load cases, and onto the right, there are combinations with the factor. It is already being taken up, right? So for the strength cases and the serviceability cases. Are you able to see the load combinations? So yes, we would be defining the load combinations, and then for the towards seeing of the results. So now how to check important. Yeah. So we would be getting the localized forces for beam plates as we have discussed. Right. So here, if you see, when we select for a beam, so we get a beam forces. However, for plate, when we say plate, you can just select with the, because we need to check the results first. For that, we just have to go to force, plate forces, and over here we can just simply select what is do. We'll have to select the load combination. Right? So which component you would be selecting, you can just select and click on apply, right? So I have to check for MY, you can just simply select with the MY, and I checked into the legion, what are all the forces that you are getting, right? The same, if you have, then you can get the actual force. Now, how typically when we are analyzing the plate forces, as you see, we are not able to get the exact bending moment diagram. We can just get the values, but for plate, how to do it? That is a question, right? How to get a bending moment diagram. So as you see over here in A, Yeah, as I was discussing about the plate forces, we get the plate forces in an element local direction, as we say, for a design purpose. So when we say design, so for obtaining the design, we would be requiring the forces along, the cut plane, maybe, the bending moment as we get for a beam. How to get when you model a typical plate element. Okay. So now the challenge is you can't directly get this thing. Like if you select the plate forces, you select the bending moment over here, plate forces moment over here. We can't get a diagram over here. How to get that? I'll explain. So for that, what we would be doing is, so let's say for mid region, if I have to simply extract this part, I'll just activate this. Now I'll just make this as active. Now here, if you see, this is my cut section. Okay. This is my cut section. And here, yeah. So here you can see that this is the plane which I am looking for to draw my bending moment diagram. So how to do that? I'll explain now. So here, if you see, we have something called as plate cutting line diagram. Okay. So for this plate cutting line diagram, if you see, we'll just have to simply select what we exactly need. So here, if you discover onto the left hand side where my cursor points, there is a cutting line diagram. Okay. So once you get this cutting line diagram, what you need to do is you just have to simply create these lines. Okay. This is the first line. You can add it. This is second line. You can just simply add this, right? Same for third line. You can just add this, click on add. So same for the fourth line. So this is from this particular point. So as you see over here, these are the four cut line which I have uh, created. Now what it is supposed to give me is the bending moment diagram. So when I say bending moment diagram, it is for a particular load case or the combination, right? So as you see over here, I can just simply plot my mx or my as the case, right? So here you can just simply select the cases over here for which you want to cut the plane, right? So this is the diagram that you would be able to obtain. So when we say a dead load, so again you can plot it for the dead load, right? So again I will explain how to check for this part. So you will have to just come to results, okay? Come to results over here, then come to plate forces moments, then use this cutting plane diagram. So I'll explain how to use this. I'll repeat this part, how to check that, because you might not directly get this. Okay. If you have to, you have already a plate model or a shell model, but now if you want to see the exact bending moment diagram, then as what we get for the beam, then we need to cut the plane in this way. So first we have added the first line. Just you have to click onto the model window. You don't have to use any of the selection command. You just click onto the first part and you just have to click onto the second part, right? So you can simply click on add. Same for first and the second cut point, add it. First and third line, yeah, this is cut line 3 and this is for the fourth part, right? So likewise, you can see now your bending moment diagram will be obtained as what we get for the beam element, right? So just check if you are able to extract the bending moment diagram out of any cut plane. Now, once the cutting line diagram is defined, then you can just simply, just check any of the component if you want. Just check if you are able to do it. So maybe if you are referring to this PDF, you'll be able to find it. Just let me get through. Yeah, it's there on page number 30. If you come to page number 30, you will find how exactly it needs to be done. So yes, so again, like there was question regarding the moving tracer also that I will come to that point. Uh, is this being done? Like, can you please confirm if it is done? You are with me, everyone? So shall we proceed ahead? So in the similar way, if you already have wanted to check the stress diagram also, even you can check the stresses. Here you just have to select the plate stresses. Okay. So once you select the plate stresses, again, if you want the cutting diagram, again, you can plot the stress diagram also. That is how we obtain the stress diagram in a plates or to get the exact total stress along the cut line, right? Because in plate, you would mostly be getting elemental local results. So you can't design for the local results over here. You just have to cut the plane and you just have to extract what is the maximum and the minimum to be designed. So now this is all about the graphical results. So now if you have to take the result table. So if you want to extract the result table, how you would be doing is, I'll explain that. So if you're following PDF, please come to the next step, which is this part on page number 31. So for the result table, you can just come to result table. Now instead of beam, we need to select plate. And here we just have to select force and stress. And then we can select any of the load combination that you want. And you can get this particular result table. Now, this result table, you can also copy into the Word form. So what you can do, you can just export to Excel over here, or you can just simply copy it from in this way as well. You can just copy it and paste it into the Word form. In this way also you can do it. So the much easy way is to export to Excel for the following load cases and the combination. Let's say if you have to prepare a report of the results, then you can use this result table. Again, result table can be used for any part, like if you want to obtain not only forces, even the plate stresses as well. So even you can go with the stress results as well. So here you can just simply select the load case and you can obtain the stresses as well, right? So this is a very format that you would be getting the results in a tabular form, where you can just simply check what is the critical stress that you are getting and you can design for it. Now, again, we have seen that how to get the model back when we are activating certain part of the model. So you can use this active all option. You can just remove this, click on apply, and you can close this. Now coming to the moving load results. So when we say moving load results, so as you see over here, So when we are checking with plate forces, right? So we would be getting, or we would be seeing a definite case for the moving load, right? So as you see over here, there are HA-HB lanes, right? For which we have to see what is the critical effect for HA and HB lane. So here we see three cases. Just everyone, just have a look over here. For moving load, if we have to run the moving load and if you have to get the results, program by default creates three cases. One is MV max, which is for HA HB lanes. Second is for MV min, which is for HA and HB lanes again. And third is MV all. So max, min, and all cases are created by default. Now, again, what is the use of this? So if you see MV max, it will create the envelope of all the sagging case. I mean, if you see, if you turn on the legend and values, you will get all the positive results. So if you, even if you check the cutting diagram also, you'll be able to see. So this gives you the possible case which are going to create the maximum hogging into the structure. Sorry, maximum sagging into the structure. Max is referring to the maximum sagging envelope. Same if you select for the min case, it will be like you'll be getting the envelope of hogging load cases. So how these envelope cases are determined, because it will create multiple positions of the load onto the bridge and it will create the most critical effect. Now, as you see over here, let's say for an example, I have to create or I have to check for a moving load. What is the maximum case? Here, if you come down, you will see that what is the max case. Max case as what point you're getting the value. If you have to change this value to numeric, I mean, from exponential to numeric form, you can use this three dot button over here. There is a three dot button. You can just press this three dot button and you can use this fixed value. Okay. So once you fix this, you can click on OK. So that into the legend, you can see that my maximum bending moment, what I'm getting is 101.48 kilonewton meter per meter. So remember, whatever the forces that you're going to get in a plate is with respect to the per meter of the plate element. Okay. Remember that. And also at the bottom, you will see the max case. So what is this max? It defines the element number. So element number is something that at 41, you are getting the maximum critical effect. Now at this point, we can just check for the moving load for a given element of maximum where we are getting the effect. What would be the position of the load? So for max, you can just simply go to moving load tracer, use this plate forces and moment option. Now here we have to enter what is the key element. So in this case, the key element would now be 41. So I'll just input this as 41 and then I'll click on apply. So as you see over here, it is giving you the, sorry, the loading diagram of the bridge where you will be getting the maximum envelope case for the sagging case, right? So this is the purpose of, using the moving load tracer to determine the position of the load vehicle onto your bridge. Secondly, also, if you have to convert this envelope case from this moving position to the static case, we also have a procedure for that. So what is the procedure? If I have to simply create into a static case, because this is just that you are getting the what we say is the diagram. So here you can see that you have been loaded with the HB, which is the point load, and the UDL case for HA. So we can see the combination of the vehicle loading position. Now, secondly, what I had been explaining is about is converting your position, the envelope position into the static case. So how you would be doing is you just use this write min max to load file option. So what this is going to do is it is going to convert your this particular position into static load case. What do you mean by that is something that you just have to check for the static load case. Now, if you change the different element, let's say if you are going to select some other element, let's say 42, it is going to give you the maximum position that it is going to get for the given set of element. Let's say I'm giving 31. So again, it position of the load and the maximum effect of the placement would change. That is how we do it. But how to determine the maximum key element is from the, let's say if I'm checking with the forces, you can go to plate forces, and over here you can click on apply, and here you can see what is the max and min. So this refers to the element position. Okay, so this is the element position. So here it is 41. So I'll just type there as 41. Going back to moving tracer. So here you can select plate forces. You can type this as 41 and click on apply, right? So that is how we use the moving tracer option. Now, again, to create the case of static load, again, you can use this write min max to load file, and then you can simply click on OK. So what this is going to do is program internally creates a static load case for you. Okay. So how this is going to get created? You can see that these moving positions are created now. Now what you need to do is you just have to copy this. You just select all using Control All, then Control C. Then we go to this apps option where we have MCT command shell, and we just simply paste it over here. Whatever the data that MCT command would give, you just have to simply copy and paste it over here, right? And just you have to run it. Once you click on run, it will show that your analysis cases will be deleted. Because why it is giving you the message? Because it is in a post-processing mode. Okay. So once you click on yes, so as you can see, there will be one addition of the load case. Okay. So once you display this, you can see this is the static position of my given moving load case, which is being currently applied, right? So it will automatically calculate the effect for the static load case. Clear? So everyone, please just check if you are able to see the results.
Hello, can you hear me, please, sir?
Yeah. Please go on.
So I want,
Sorry?
sorry, can you hear me now?
Yeah. Now I can hear you. Yeah. Hello, we lost you. Hello.
Hello, can you hear me?
Yeah, now you can hear. I can hear you now. Yeah.
I'm having network difficulties. I have a question.
Yeah.
Okay, so what's the essence of doing all this, please?
Sorry?
How do you start the design and you use this to do the design or what? I'm a bit
Yes.
lost.
No problem. We haven't started yet the design part. We are just seeing the analysis part only as of now. Okay. So we would be starting soon with the design. If you are expecting design, then we would be following from page number 33 or 32, sorry. Okay. So if you are following with the design, just I request you to wait so that we can start after the analysis is done. Okay. Yes. So, if you have any questions in analysis part, please confirm. Otherwise, we'll move towards the next part, which is the design part. Okay. Any questions so far? Till the analysis part, please confirm if you are able to do. Yeah, sorry, I think there was a disruption again. Uh, uh, Dear host, can you just allow me the access to share? I think I lost that. Hello, hello.
All right, please go ahead and share your screen.
Okay, perfect, perfect. Yeah. So yes, we would be starting with the design part now. So what I had been explaining about is the converting, so the nodal positions. And once you analyze this part, you can even check the forces or the stresses for the plate, even for the given dead load case, right? So here you can just simply select the load case which is being generated, and you can see the results for that as well, right? So again, you can turn on the legend and the deform positions also you can check, right? So this is something that you can see the results in a graphical and into the results form. All right. So now we would now go to the next step of design part, okay, which is the final part for today. Like we would be completing the design of box culvert, and further we would be going to the next example. All right. So now let's do it with the design step. So everyone just come to the next step of the design on page number 32. Okay. So come to page number 32. We'll be defining from there. So here, just come to the design part. Okay. So here again, we would be selecting the code as BS code. Okay. So simply select BS code over here. So first select the RC design. Okay. Is everyone there? Please confirm. If you are still lagging, please let me know. I can wait, or else we can move towards the design step.
Wait a little bit.
Okay.
Yes, design. Then you select. Yes. Let me reach my mic.
We are all there, I think.
Okay. So let's move ahead. So come to page number 32. Okay. So we'll continue from page number 32. So here we would be first looking up for the RC design. So come to design tab. So there is a design tab over here, right? Yeah. So in this part, you can just come to this RC design and here just select BS code 5400 that we would be using for the design. Now the very first option is the design code option. Here just simply select the option of code and the beam type as singly reinforced as we want. And then we also consider the axial moment interaction for plate column. So click on OK, right? So after that, the next step we would be doing is defining the or modifying the material. So just come to this modify RC material, click onto this part, and here just update the grade of rebar. Since it is already defined, we just have to define what is the strength of the rebar over here. So here you can just simply use this VS code. Just define the grade of the main rebar and sub rebar. So I'm adopting as S460, and for sub rebar, I'm adopting as S250.
Sorry, please.
No problem. I'll explain again. The very first step is completed, defining the code.
We've selected design code to BS, right?
Yes, that's right.
Then what again?
Then come to next step of defining modify RC materials. Now, why this step is, since let's say if an engineer wants to design to some other grade, or at some point, if you have to update the design criteria for the compressive strength of the concrete, then we can simply assign it here itself rather than going back and doing the analysis. Okay. And also these steps serve to use or to update the the strength of the reinforcement as well. Okay, so that's the reason why we are doing this step. So you'll find that two options over here to get or modify RC materials.
We are with you.
Yeah, perfect. Now let's go ahead. So once you define the modify concrete material, just update the compressive strength of the concrete if you want, and also the strength of the rebar. So here I'm selecting the BS code. I'm defining what is the main rebar and also what is the grade of sub rebar. Now the next step which we would be doing is come to page number 33. Come to page number 33. Now we would be just assigning what is the minimum spacing. So go to the next step on page number 33. Okay, so we would now be updating the rebar. So here, go to this particular part, then use rebar input for design. Okay, so just check this particular step over here. Okay, on page number 33. So here you can just come to this particular RC design tab, and over here you can just use this option rebar input for plate. There is a specific option for plate input. So here you can just use rebar input for plate design. Okay, for beam specifically we are selecting. Now here we just have to select what is the subdomain, okay, which we are designing. So we have to add it over here. So what is the stirrup size and what is the number that we want to adopt? So I am adopting as 4 leg and I'm adopting a spacing of 40 mm. So the input would be 0.04. And then you can click on add. So here it is asking the main rebar direction, right? So you can add it over here. Same, you can do it for the mid slab. If you want to change for mid slab, you can just simply update it. And further, you can just use this option to just modify as required, right? So we have to define this particular plate beam data for design, right? We are following from page number, if you are following from tutorial, page number 33. Okay. So just complete up to this part. Then similar way, we have to input, just that we have to input, okay? Same for like what we have done for rebar input for beam. Same way you have to input for column also. So you can just input rebar input for plate column design. Okay. So for column, you just have to add the walls. So here we go with average element results. Just select the rebar direction, number of rebars, 2-legged or 4-legged. Then distance you can adopt as 60 mm or 45 mm as required based upon the exposure conditions that we would be having. So I'm adding for bottom wall, mid wall also, and also for the top walls. right? So in this way, you can just simply define for the design criteria. We just have to add, okay, over here. So in the similar way, do it for plate beam data for design, and one is plate beam data for column, okay? There is a design option, not checking. We are not doing with the checking as we want the design reinforcement in total. So we are just using this as design part. Now, what is this checking? I'll explain later. It is just that you input the reinforcement and just check if it is optimized or not. Okay, so that will be the later part. I'll explain.
We are with you. Can we do that? Can we do what you just did?
Yes, yes, please go on. I'll wait. Yeah.
Okay, we have just done that, but I have a question, please. Can you hear me, please, sir?
Yes, sir. Please go on. Yeah, yeah.
Okay, and in this column data is
Mm-hmm.
the stirrup in the under stirrup data is the
Yeah.
number 0.
Yes. That is not number zero. That should be either we are assuming stirrup as two leg stirrup, four leg stirrup, right? So I am adopting as four.
Oh,
Yes.
what about the one of beam?
Sorry.
Can you do you get my question? My question is
Mm-hmm.
when adding a column data
Mm-hmm.
under stirrup data, we have
Yes.
size and number. Size
Yes.
is 6
Yes.
and the number is what?
Legged. Legged. Stirrup had two leg stirrup or four leg stirrup, right? So if it is two legged, we are inputting as two. If it is four legged, it is four leg stirrup. So basically, it is going to calculate the total area of the stirrup reinforcement. So if you say P10, so P10 would be having a specific area multiplied by that numbers, right? So we have the stirrup, right? So either it is a two-legged we need to adopt or four-legged we need to adopt. So that is the number we input over here.
Okay, okay, thank you. What about the one of beam? Is the number 6?
Yeah, that is the number. Yeah, we would be adopting six-leg stirrup.
Thank you.
Yeah. Clear. After that, we'll move towards the next step, which is the final one. You can just come to page number 35. Okay. So here we can just see onto the page number 35. We'll be going with beam design. So here you just come to this RC design, and over here you use this plate beam design option. Okay. So under plate beam design, as you see, you will be able to design this. So you can see this particular dialog box will appear, and now you can just check the results for, the left hand slab or the mid slab that you wanted to check. So let's say if I have to check for mid slab, you can use this graphic option, and under this you can see what is the total rebar required. So you can see over here the total rebar pattern for top is 0.00465 meter square per meter, right? Same if you see the bottom reinforcement required, it is 0.000863133 meter square per meter, right? Also, it will showcase the utilization criteria as if the bending moment capacity check is okay or no. Also, okay, so you can just check it over here. That is the for the given demand for the entire mid slab to be designed, what is the strength check, right? So that you can check over here. Again, if you want a detail output, you can just use this detail report. So you can get a Word file of entire detail report as what is the total depth, what is the cover that we have adopted, and all the design checks, right? So this is a detailed report that you can see. You can find it all the stress check to be done as per the codal provision. Also, it will provide what is the code reference that is being used. Onto the right, you can find the clause number. Okay. So it is very, what I say, very more detailed report when you come to RC design of such structures. So even it will design for
Thank you.
shear. Yeah, it will depend for moment capacity for both flexure and positive and negative, right? With regard to domain and subdomain, right? So that's the purpose that why we have, done this particular thing to understand how typically we would be getting the design forces with regard to the domain as when we do practical. If you say practical application, so it is just that we need to have the curtailment at some point. So that can be easily be done using these options, right?
Thank you very much.
Yeah, thank you.
So can we do that now?
Yeah, you can do it now. You can just check for designing the beam and also for the column. I have just designed the beam. Now in the same way, you can go to RC beam design and you can perform plate column design. So column, the side walls to be designed. You can just simply check the column to be designed over here. And also you can just see the detail, you will get all the column design check with all the PM interaction curve, axial and bending moment capacity check. So everything would be obtained as per the code provisions, right? So this is something that you can get a detailed output, and graphical report just gives an rough idea about what was the, a very brief report about what is the top reinforcement, what is the bottom reinforcement as a structural engineer, what we required for the forces for the getting demand is satisfied or not. So that we can check it in a graphical report, right? So you can do it now.
Okay.
Yeah.
Thank you.
Thank you. Please check if you are able to generate the report or not.
We have been able to.
Please check if you are able to generate the design report or not. It is just that we have few steps for the design. We just have to input what exactly we need the parameters for the design output position. In the same way, you can also get the detailed output for that, right? So this is the complete Word document or the design document we would be getting for both column design and also for the beam design.
Hello, can you hear me, please? Can you hear me, please? Respond if you can hear.
Look.
Everyone, please check. Hello, hello, hello.
Hello, can you hear me, please?
Yeah, I can hear you. I can hear you. Sorry for I got disconnected. So yes, are you able to extract the report?
Yeah, I've exported the results, but there's
Okay.
this graph that's showing in your work. I can't find it.
The graph, like the PM interaction curve.
We can't see your screen anymore, Akshay.
Yeah, I am just sharing this. So you are able to get this like report, everyone? Yeah, hello. Can you just check you're not able to get this report because we have to perform the column design. So for that, we have to go to RC design and perform plate column design so that you can get this particular PM interaction curve diagram.
We're with you, please carry on.
Yeah, perfect. So yes, so you can just see this in detail and you can just cross check your design if it is satisfying with, the requirement, and you can submit this ready-made report of the design as per the code, right? So that is how we do it as our design at Culverts. And even if you see the demands we designed for the moments and forces that we are getting and the stress limits are being checked using this particular report. You can also see the detailed report over here in the Word format where you can see all the stress check at what particular element we are having the maximum combined capacity of both axial and moment capacity for both, again, for positive and negative flexure, right? So here we have this all the detailed report. All right. So I think we have completed up to design stage. The elaboration, maybe you can just go to detailed report output and just check if if you are getting the design generated or not. I mean, you're verifying your design with any example that you wanted to do. Okay, with Midas. So yes, I think we have finished the culvert part for today. Right from analysis to the
Hello,
design and
engineer
modeling
Akshay,
part.
please can you hear me? Confirm if you can hear me,
Yeah, yeah, I
please.
can hear you. Yeah, yeah, please. I think we can wait for
I was
queries now.
Yeah, I was able to generate the result, but my question is that in the results, in yours, I can see that you have sort of a graph. I
Yeah.
can't find that in mine. Can you hear me, please?
Uh-huh. Am I am I audible to you?
Yeah, you're audible now.
Yeah. So okay. What you can do is, are you able to generate the plate column design report?
Yes, yes.
Okay. So if
My
you come to,
question, yeah.
yeah. So here what you can do is, here you can just come to this part, right? Over here, you have selected plate beam, sorry, you have selected here as plate beam design and one is plate column design, correct? So in plate column design, you would be getting a detailed report of this. Are you able to get this report?
Yes, I got the report. The
For
question
the
is that in the
walls, for
report, you
the
might
walls,
have,
right? For the walls, right? I'm designing the walls.
yes,
So walls would be designed as your column, right? So in
yes,
this, if you come
yes.
down, you are not able to see the PM interaction curve. Are you able to see the PM interaction curve?
My question is that in
Yeah.
design, I saw
Yeah.
yours and I saw some kind of graphs. So in my result, I can't see that. Were you able to generate that, please?
You mean that you want me to show how it is generated?
Yes, how it is generated with the graph inside.
No, it directly comes. I mean, it is the automated report that programs gives you. I have not done or inputted anything over here. The program directly gives you the standard graph. Am I getting your question, or I'm
Okay, can you show me a result so that I can confirm?
yeah,
Yes,
yeah, sure.
please. I can't see the graph in mine.
Okay. Maybe, like if you are checking with Beam, you won't be able to see the graph. However, when you're checking with column results, then you can get the graphs. That is a PM interaction curve diagram. Let me showcase. Yeah, let me show. Just a bit, I'm opening. Just give me a minute. Yeah. Can you just see the screen now? Hello, hello. Can you hear me?
Yes, it's all good. You can
Yeah.
continue, please.
Yes, yes. So over here we come to design part. Okay. So in design part, you can just simply come to this uh yeah, RC design, right? So in this, you can use this plate column design. Are you able to see? So once you perform column design, you can just click onto this, any of the uh, you know uh, domain that you have to see the result. Click on graphic, then you can see this particular graphical result output. Second thing, if you want to find it in a word form, in a detail form, you just have to click on detail. Can you just check? Hello?
Can you come again, engineer, please?
Yeah, sorry, I can get you. You are able to get the graph now?
Let me do it, please.
Yeah, yeah, sure. If there are any other questions from today's session, please let me know. Otherwise, we have almost done for the day. Like we have completed from both the 2D and the 3D culvert design. And yes, so if there are any question in both of the examples, please let me know so that we can discuss.
Okay, I've gotten it. Thank you for your
All right.
lecture
Thank you.
script.
Thank you. No problem. Yeah. Any questions so far? So if there are no questions, I think we can call off for a day. We can wait here and we can just
Um, Actually,
yes.
yeah, well done for the job, well done. But if we're going to do a multiple cell coverage,
Yeah,
what's the
yeah.
principle?
Yes, yes. Again, it's on the similar lines. With regard to design you're talking.
Yes,
Okay. So for this
both
part,
both analysis and design.
yes, yes. So let me explain with that. So what we would be doing here is, it is as simple that we go on creating the model as 3 cell box. It is just that we just have to input the span as required, multi-cell box, and rest of the definition remains the same, right? So whether it is like the position of the loads or applying the moving load, it is all going to remain the same. So if I have to show you how typically you could go with the modeling, it is very easy. Let's say if you have a multi-cell box, you can just simply create the model as a 3 cell or multi-cell box. Maybe it is could be conforming to vehicular underpass, or maybe a kind of passage for water or any retaining liquid, right? So for that purposes, it is simple to do or model it using Midas. So let's say I have to create some span of 5.35. This is my first span. Next span is, let's say, 6 meters. Then again, I have 5.35. This is an uneven span that I have to model. So what I can do, I can input in this way. Sorry, I have put a comma. It should be 5.35. Yeah. So in this way, you can enter the details of your cell. Even if you have the skew, even you can enter the skew angle. And again, you can generate a model. And also in the same way, you can go on performing the design. Maybe, as a case study, maybe you can take it as a challenge to do or model that. And you can just cross verify with your manual calculations as well. So this is going to be, a kind of practice for everyone to do, or come up with the design forces for a typical box culvert.
Hello.
Yeah. Hi, engineer.
Yeah, thank you so much. Thank you for today. Although I was just learning, so we'll go and practice later. Back to my question that I asked earlier because of time, so I know you didn't really pay me attention. I Please, can you show me how to change my skill?
Sorry, how to
Can you
change?
to change my the skill, so that I can be able to see where to do add or close when a drop down box shows.
Okay. I'm not really able to get your question. You are able to view, right?
You open now to show the last question that you were trying to change the to impute values. There's a drop box you open.
Okay.
Can you
This
just
one,
open it?
like the culvert wizard?
Something like this. At the bottom, there's where
Yeah.
you say okay.
Okay,
Where
okay.
you
I got the issue. Like you're not able to see the
say
OK and the apply command. Maybe what I will do is I will connect to you after the session. Maybe like once we wind up, I will connect to you using the local system, and I will just check the issue onto your system. Okay.
okay, thank you
I
so
will
much.
resolve that. Yeah, no problem. That I got the issue. Yeah. Anything
Okay.
apart from that?
No.
All right. I hope everyone have got the today's session, as like we have completed this part. And all right. So engineer level, can we conclude for today?
Yes,
Hello.
in the absence of no further question, believing
Okay.
that everybody enjoyed the session, I
Right.
say we close for today till tomorrow. Tomorrow will be hybrid for those in Lagos, where we'll be at the NSC Secretariat in Ikeja. You can be there if you have some personal issues to discuss with the resource person. Thank you
Thank you,
for your
everyone. Thank
participation.
you,
Thank you.
everyone. Yeah.
Thank you, everyone. Do have a wonderful evening. Thank you to our facilitator who took out his time to explain in details. Have a wonderful evening, everyone. I will stop the recording now.
Thank you very much.
experience.